Here I have a quarter. A quarter has two faces, usually called heads and tails. So if I flip that quarter and I want to record what happens, think about all the possible outcomes. Well, I could get heads or tails. So I write a sample space containing H and T. I'm going to represent heads with H, tails with T. You could write out the words heads and tails, it's just more writing. Remember, sets can contain anything, letters, numbers, other sets, words, whatever you like. Just H and T is a convenient way to represent heads and tails. Similarly, suppose I got this little Rubik's Cube. I don't have a die, but I do have a little tiny Rubik's Cube. You could roll it like a die. And if you roll it, there's 6 possible outcomes. So if I want to write out a sample space for the procedure of rolling this Rubik's Cube die, then it's going to have 6 things in it. Let's see. The white, yellow, red, blue, green, and orange, I think. Right? White, yellow, red, blue, green, and orange. Good. Suppose now I do something slightly different. Let's turn one of these faces. Now let's suppose I roll this thing, and I count how many orange squares I see on top. Well, let's see. You could get no orange squares, you could get 3 orange squares, or you could get 6 orange squares. So if what I'm counting is the number of orange squares that appear when I roll this thing, then I could have none, or I could have 3, or I could have 6. So there's a sample space for the experiment of rolling this thing, counting the number of orange squares you see. So that's a good one. Finally, let's do one where we put these things together. Let's suppose we do both things. We'll put the die back to normal solved Rubik's Cube. And let's flip the coin and then roll the die. So flip the coin, roll the die. Whoa, okay, what did I get? I got tails, blue. So if I want to count all the possible outcomes of flipping the coin then rolling the die, let's see, I could get tails blue. Well, basically, for every time I flip a head, I could get each one of the 6. And every time I flip a tail, I could also get each one of the 6. So in total, if we list all the outcomes, you could get heads white, heads yellow, heads red, heads blue, heads green, and heads orange. And similarly for tails, I could get tails white, tails yellow, tails red, tails blue, tails green, and tails orange. So to finish off, I just want to point out this example where you rotate one of the faces. I think is good because it emphasizes that if I just give you a procedure and ask you to write a sample space, what's the best sample space? Well, it depends what you're counting. It depends what question you want to answer. If what you care is, when I roll this die, what comes up? Okay, I care about the color that comes up. Sure, I have all the colors in my sample space. If what I'm doing is counting the number of, so we saw in our example, orange squares that you see, well, if I didn't change the Rubik's Cube at all, my sample space would just have 0 and 9. Because it's 0, 0, 9. And when I did this, okay, now I think about all the possibilities for number of orange squares that could come up. I have 0, 3, and 6. So the point of a sample space is to give a nice representation of all the possibilities for all the outcomes of some sort of chance procedure, but that obviously depends on what an outcome is. What are you counting? Are you counting the colors of the faces, or are you counting the number of orange squares that give you a different sample space?